Here's August 2015, questions 25 to 31. 25 says, each day Tony records the height of a plant for her science lab. Her data are shown in the table below, and you're looking at day, represented by n, and height in centimeters. So the plant continues to grow at a constant daily rate. Write an equation to represent h of n, the height of the plant on the nth day. Well, if I look at my y values, I am going to figure out what the pattern is. So the pattern is that each day I'm going to add 1.5 centimeters. So the plant is growing 1.5 centimeters every day. So my equation has to start off with h of n, and it's going to equal the slope, which is 1.5, times n, the number of days, and then we're going to add our y-intercept. But since we don't know what our y-intercept is, based on the table, we can figure it out. So if we go back a day to day 0, starting with 3, we're going to have to subtract 1.5, and you'll figure out that the height at day 0 is 1.5. And so this is your equation. Number 26. On the set of axes below, graph the inequality 2x plus y is greater than 1. In order to graph this, I need to set y alone, so I'm going to subtract 2x from both sides, and I'll end up with y is greater than negative 2x plus 1. So my b value, my y-intercept is 1, my slope is negative 2, and if you want to put it as a fraction, it's negative 2 over 1. So what you're going to do is start with 1 on the y-intercept, and you're going to go down 2 to the right 1, down 2 to the right 1. Because this doesn't have a line underneath it, it's not equal to, it is going to be a dotted line. So there's my line, and now because it's greater than, I'm going to be shading above. And that's my final solution. 27. Rachel and Mark were given the information shown below about the bacteria growing in a petri dish in their biology class. So we're looking at number of hours, x, versus the number of bacteria, b of x. Rachel wants to model the information with a linear function, and Mark wants to use an exponential function. Which model is the better choice, and explain why you chose this model? Well, in a linear function, you're repeatedly adding the same number each time, and in an exponential function, you're repeatedly multiplying the same number each time. So what I'm going to do is look at the y values, and I'm going to start with looking to see if it's close to a linear model. So I'm going to write down the y values, and I'm going to start with 220. Okay, so I only wrote down a few of the y values, and if I look from 220 to 280, I'm going to have to add 60. From 280 to 350, I'm going to have to add 70. From 350 to 440, I'm going to add 90. From 440 to 550, I'm adding 110. And from 550 to 690, I'm adding 140. So as you can see, there's no number that we're repeating each time when we add. All these numbers are different. So it doesn't look to be a good linear model, but let's check out the exponential model. Okay, so I'm going to still write down these y values again, starting with 220. Okay, so here are my y values, and what I'm going to do is divide 280 by 220 to figure out what I'm really multiplying by. So 280 divided by 220 is 1.27. So that's what I'm multiplying by. And if I go from 280 to 350 to figure out what I'm multiplying there, again, I'm going to take 350 and divide by 280, and I'm going to get 1.25. 440 divided by 350, I'm getting 1.26. 550 divided by 440, I'm getting 1.25. And 690 divided by 550, I'm getting 1.25 that I'm multiplying by. So if we look, it seems that our exponential model would be the better choice because the number that we're multiplying by each time is very similar. It's almost exactly the same number each time. Okay, so when it says explain why you chose this model, you're going to have to say exponential because the growth factor, which is the 1.25, I'm going to do this squiggly because it's not exactly 1.25, but it's about 1.25, is more consistent than the linear function, because the linear function is adding a different number each time, okay? So because the growth factor is roughly 1.25, we have a growth factor. Number 28, a driver leaves home for a business trip and drives at a constant speed of 60 miles per hour for 2 hours. So constant speed, 60 miles per hour for 2 hours. Her car gets a flat tire and she spends 30 minutes changing the tire. She resumes driving and drives at 30 miles per hour for the remaining 1 hour until she reaches her destination. On the set of axes below, draw a graph that models the driver's distance from home. So our y value is our distance in miles and our x is our time in hours. So if she's going 60 miles per hour for the first 2 hours, that means that at 1 hour she'll be at 60. At 2 hours she'll be at 120. So this should be a nice straight line because you'll have a nice ruler. Okay, so it says her car gets a flat tire and she spends 30 minutes changing the tire. So that means that she didn't go a distance for 30 minutes. So that we have to do that little horizontal line right there. And then she resumes driving and drives at 30 miles per hour for the remaining 1 hour until she reaches her destination. So she's only going 30 miles per hour and it's going for the remaining time. So that's going to be a line like this. Okay? So she'll end up spending a total amount of time at 3 hours, 30 minutes, and she went a total of 150 miles. (29) How many real solutions does the equation x squared minus 2x plus 5 equals 0 have? Justify your answer. Well, one thing you could do is type this into y equals, and you could look at the graph. Okay, and your graph looks something like this. Okay, and so based on the graph, you could say that there are no real solutions since the parabola never crosses the x-axis. Okay, that's one way of saying that there are no real solutions. The other way would be algebraically, and you would use the quadratic formula. So to use the quadratic formula, you would say a is 1, b is -2, and c is 5. And you would plug it into the formula, so it would be x equals +2 plus or minus the square root of -2 squared minus 4 times 1 times 5 all over 2 times 1. This gives you 2 plus or minus the square root of -16 over 2. Okay, the square root of -16 is imaginary. That's an imaginary number. Therefore, no real roots, okay, or no real solutions. Number 30, the number of carbon atoms in a fossil is given by the function y equals 5,100 times 0.95 to the x, where x represents the number of years since being discovered. What is the percent change each year? Explain how you arrived at your answer. Well, this formula comes from the formula y equals c times 1 minus r to the power of t. The reason I know it's 1 minus r is because it's 0.95 and it's less than 1. So my y equals, it's really 5,100 times 1 minus some r value to the power of t, and in this case it's x. So to figure out what that value is, I'm going to say that 1 minus r is equal to 0.95. So I'm going to subtract 1 and get negative r is equal to a negative 0.05. Divide by negative 1 to get r to be positive. So r is a positive 0.05. So that's what our r value is. And so the percent of change, if it's 0.05, to make that a percent, what we're going to do is multiply that by 100. And so we'll end up with 5%. That is the percent of change each year. Okay, and explain how you arrived at your answer. Well, we knew to use this formula because your b value is less than 1. So you could say that you used this exponential decay formula because your b value is less than 1. 31. A toy rocket is launched from the ground straight upward. The height of the rocket above the ground in feet is given by the equation h of t equals negative 16t squared plus 64t, where t is the time in seconds. Determine the domain for this function in the given context and explain your reasoning. Well, domain is talking about x values, and since they don't have any x in the equation, it's really talking about your t, which is your time. So if I type this into my graphing calculator and I look at my x and y values, which in this case is really t and h of t values, time and height, I'll look and I'll see that 0 time is a 0 height, a time of 1, which is talking about, so 1 second, is a height of 48, and that height is in feet. 2 seconds, I'm at 64 feet. 3 seconds, back to 48, and at 4 seconds, I've hit the ground and I'm at 0. So the domain is going to be from 0 to 4. This is your domain, okay? And explain your reasoning. Well, you can't have negative time, okay? So we start time at 0 and we end when rocket hits the ground. And that's when your y value is 0.